All right, today we're going to learn the day one of our new unit on circles. Day one is going to start out with some basic definitions and some recall and some basic theorems. Okay, all right, start with this. This photograph was taken 216 miles above the Earth. From this altitude, it's easy to see the curvature of the horizon. Facts about circles can help us understand details about Earth. Okay, a circle. Circle is a set of all points in a plane equidistant from a point, which we call the center. All right. Inside of the circle, we have some special segments. Of course, we have a diameter that goes from point on circle through the center to a point on circle, and we have a radius which goes from the center to any point on the circle. We also have some things you're not familiar with, like a chord. A chord is a segment whose endpoints lie on the circle. So it's very similar to a diameter. Basically, a diameter is a chord. It's just a special segment. Okay? A secant is a line that intersects a circle at 2 points. A tangent is a line that intersects a circle at 1 point. The point of tangency is the point of intersection of the tangent line and the circle. Okay, so now we're going to draw some of these. So if you have a ruler, where did mine go? Here it is. You can use it. Take on first, go over here and try to find the center here. I'm going to call it A. So this is called circle A. All right, I want to start with all by drawing things we know. I want to draw a radius. Again, I can draw to any point, any segment from that A to a point on the circle is a radius. So segment AB radius. Okay. All right, I want to erase that A. All right, so I want to extend my radius. I want to draw another radius, opposite one I just drew. And so now we have a segment CB that is a diameter. Okay. All right, so now let's do some new segments and lines. So if I was to put a point here and put a point over here and then draw a segment, I want to draw a line. Draw a line through them, looks like that. So A, B, C, D, E. Okay. So what I have here, people mess up on this, so be careful. We have a line DE. So DE, and this is called a line, is called an secant. Inside this line, however, if we were to stop at D and stop at E, this is a segment inside that line. So we could say segment DE is going to be a chord. Okay, so now we need to do a tangent. So I'm going to first put a point. Then I want to go up here and I want to draw a line. Now remember, inside a line, inside every line, there's a segment. There's segments. So don't think you have to be a line. It can be a segment as well at times. A, B, C, D, E, F. Okay, we'll put another letter on here, G. You could have a script letter like L. So I'm going to put over here F, G, line F, G in this situation. It's a tangent. All right, so there's your definitions and things you need to know. Pairs of circles. Two circles are congruent if and only if they have congruent radius or radii. You could put diameters as well. All right. Concentric circles are coplanar circles with the same center. And tangent circles are two coplanar circles that intersect at one point. Now you can draw these if you want to. I'm just going to go over here real quickly. I'm going to draw best I can. So radius is 2. Radius is 2. All right. They share the center. So it means you're going to have one circle and another circle inside. And there's those. And then these could be inside or outside. So this would be easier for me. Just going to draw it inside here. Just going to put a point there and kind of draw through that point. Now they won't have they won't necessarily have the same point. Okay? All right. Sorry, you can't really see that. All right, so here, number one, we're going to do what we did a while ago. We're going to look at everything and identify everything. So I'm going to do number one together. Number two, you can do it by yourself. Again, you can stop this anytime you want to, rewind it, fast forward, whatever. So let's see here. I got 1, 2, 3 radii. So I have JL, comma, KL, comma, ML. These are all, every one of those are radius. Okay, so next, let's see here. I have point J and M, and they're not going through the center. So point JM, or segment JM, excuse me, is going to be a chord. I see another chord, but it's a special chord, KM, it's diameter. And then I see that I have a line going through J and M. So I can put JM. If it's a line, then we have a secant. And last but not least, I see over here, this line M is intersecting at one point H. So we can say line, just try to do the best you can, M as a tangent. All right, number two, you do stop it and try it. Okay, here we go on number two. Let's see how you did. Hopefully you do well. I see QS. Oh, no. I don't see QS. I see QP. QP, TP, SP, and there's a radii. I see ST, that's a diameter. I see the line ST, that's going to be a secant, even though it goes through the center. I see line UV, tangent, and I see segment QR, chord, and I believe that's all I see. Did I get everything? Hope I did. All right, let's move on. Number three here, real quickly. Find the length of each radius. So we're going to do the best we can. So that's going to be 1.5, and that's going to be 2. So radius of S. So these are not be congruent circles. And we're going to write a, identify the point of contingency. So it looks like right there, it's going to be negative 2, 0. So negative 2, 0 is the point of contingency. So write an equation of a line at this point. So we're going to write an equation right here. That's touching that at that point, both of them. So that's going to be a horizontal line. So that's going to be y equals 0. All right. A common tangent is a line that is tangent to two circles. If they are tangent on the outside of the circle, like this is external. If they go through the circles like this, it's internal. I wouldn't worry about that too much. You may want to just remember. All right, here we go. If a line is blank to a circle, then it is perpendicular to the blank drawn. So the word here is tangent. So if you have a tangent line, it's going to be perpendicular. What does that mean? Right angles. It's very important. To the, look over here, that's a radius. Drawn to the point of tangency. So this right here should be a, so let's see, I don't have 3 points. So I won't put a point on here. C. So angle ABC is a right angle. It's very important there. Okay. All right, the converse means backwards. So if a line is perpendicular to a blank of a circle at a point on the circle, then the line is tangent to the circle. So what? The line is perpendicular to the radius, to a radius, then it is going to be tangent. Again, perpendicular. So you have to prove or show right angles. If you see a right angle, you can conclude that line M is a tangent. If you don't see a right angle, then you have to prove that that's a right angle in order to say that we have a tangent here. We'll see. We'll get back to that. Sorry, I'm just discombobulated. No, it's right here. I was right the first time. If you can prove that there's a right angle, then that line's going to be tangent. I was right the first time. Sorry. All right, here we go. If two segments are tangent to a circle from the same external point, then the two segments are going to be congruent to each other. So AB is congruent to AC, which means that the measure of AB, okay, let's do this real quickly. Measure does not have a symbol. No symbol for equals. All right, here we go. We got two quick ones here, pretty simple. So what I see here, I see an external point of H. I say that this is a tangent and that's a tangent. They'll be touching at K. That means if I was to draw a radii here, it'll be right angles there, just FYI. So we know that these will be congruent to each other. So 4 plus 2a equals 5a minus 32. I'm going to subtract 2a from 5 and get 3a on this side. I'm going to add 32 and get 36. Divide by 3. And I believe we get 12 equals a. But I'm not looking for a. I'm looking for hg. To take hg is 4 plus 2 times 12. 24 plus 4 would be 28. All right, you guys do number 5 quickly. Think through the problem like I just did. All right, here we go. We have x on the point of R. It's got two tangents coming from it to the same circle. So therefore, those segments that it's making, tangent segments will be congruent to each other. So n plus 3 equals 2n minus 1. So 1 there. Going to subtract 2 from 1, I get a negative 1. Subtract 3 from negative 1, I get negative 4. And I get positive 4 when I divide by negative 1. RS is right there. So it's going to be 4 plus 7, which would be, 4 plus 3, which is 7. There we go. All right. Almost finished. So, using our theorems, we can say that AB is what? AB is going to be a tangent because it's forming a right angle with the radius. Okay? How do we know? I just said perpendicular to radius. Okay, so good enough. All right, so we got to solve for the radius. What is the radius? So I have a right triangle, so I want to use Pythagorean theorem. Well, this is a leg and that's a leg because they form the right angle. So we have r squared plus 30 squared equals, now that part's r and that part's 18, r plus 18 squared. All right, so here we go. R squared plus 900 equals, now remember this is base times base, so r plus 18 times r plus 18. So r squared plus 18r plus 18r plus 18 times 18. I think it's 364. 18 times 18. Oh, 324. So 324. All right. So we can put everything on one side because I see these. But when I move that over, what happens? They cancel out. So now I go from a quadratic to a linear. So 900 equals 36r plus 324. Subtract 324. So I'm going to go over here. I got 576. Divide that by 36. So the radius is going to be 16. All right. So number 7 is AB a tangent to the circle. How are we supposed to know? Well, the thing is this a right angle? Which means perpendicular. Well, how do we find that out? Well, we can use the converse of Pythagorean theorem again. If these numbers make this true, then it is. It's got to be equal though. All right, so 48 squared plus 20 squared equals 60 squared. Now I can use our calculator for this. We don't need to write everything down. So 48 squared plus 20 squared equals, 2704. We know that this is going to be 3600. So it looks like to me, it says show, so I'm showing that it's not a right angle because they're not equal to each other. Make sure I did that right. 48 squared plus 20 squared. And then, all right, looks good to me. Okay, let's go ahead and answer some questions about the horizon that we talked about earlier about the looking from outer space. Early in this flight, the Apollo 11 spacecraft orbited Earth at an altitude of 120 miles. What was the distance from the spacecraft to Earth's horizon rounded to the nearest mile? Okay, so we'll look over here. E is the spacecraft. You look at the curvature, look out horizontally at the curvature, and you're going to eventually hit a point that's looks like it's going to be on the Earth or the circular of the Earth. And remember, a radius drawn to that point where you see is a right angle. It's a right angle. All right, so this says right here the radius of Earth is about 4,000 miles. So that means that DC also going to be 4,000 miles. All right, so above the Earth from D to E represents the height of the Apollo 11, so it'll be 120. So we have enough information to find a missing part of a right triangle. So we have leg 4,000 squared. We have a question mark. We'll call it x squared. And over here we have 4,000 plus 120. So that's 4,120 squared. So before I use my calculator, I want to just subtract 4,000 squared from over there. Okay. Now, if you have a good scientific calculator or calculator, then it should be easy. 4120 squared minus 4000 squared, and we get 974,400 equals x squared. So we want to square root both. We're going to the nearest mile. So we're going to square root 974,400. And I got approximately 312.15. The nearest mile is going to be 312 miles. Okay. All right, let's do another one like this. Okay, number 7. Kilimanjaro, the tallest mountain in Africa, is 19,340 feet tall. What is the distance from the summit means top, of Kilimanjaro to the horizon to the nearest mile? Okay, so we may want to draw a circle for Earth. We know that from the Earth up, where Kilimanjaro is located, is 19,340 feet. We know that from the center of the Earth to the crust of the Earth is 4,000 miles. Okay, let's make this a little bit more sensible. So if this person looks, we need to draw a radius at a point of tangency right there. So that should form a right angle, and this is radius also, which would be 4,000 miles. So we have these in miles, but that's in feet. So what I want to do, I'm just going to take this and divide it by 5,280. 19,340 divided by 5,280, and you can go on put 3.662. I didn't round. I just wrote out the 3 digits. So that right there, the height is 3.662 miles. So now I'm ready to find the distance from the top of Kilimanjaro to the horizon. So we're going to do the same thing now. We got Pythagorean theorem. This right here is 4,000 miles. We don't need to put for miles. Let's put 4,000 plus this is x squared, which is the other part of the right angle, which is the leg. This is 4,000 plus 3.662 squared. We're going to subtract 4,000 squared. All right, so 4,003.662 squared minus 4,000 squared, and we get x squared equals, we'll not round, okay, now we're going to square root both sides. So we're going to square root 29309.410. All right, so x is approximately 171.19, which would be approximately 171 miles. Okay, you try the next one. I want you to practice drawing the picture, because you may be asked to. You never know. Always be prepared. And I want you to do everything. So stop the video and go. All right, so hopefully you had a chance to do that. So quickly, here's my circle. Here's my Earth. There's 4,000. Let's see what I got here. Mount Mitchell. So Mount Mitchell is going to be somewhere right here. I'll put M for Mitchell. Let's do this better. I need a. Okay. Let's draw Mitchell. There's Mitchell. Let's draw a tangent line from Mitchell to the. There we go. Now I can draw that. And I can draw that. They're both 4,000. Trying to find that. This is 6,684 feet. So I had to divide that quickly by 5280. That was about 1.265 miles. All right, so we have 4,000 squared plus x squared equals 4,001.625 miles squared. Subtract 4,000 squared. Okay, so 4,001.265 squared minus 4,000 squared. All right, so x squared equals 10,121.60. Square root both sides. 10,121.6. Boom. So x is approximately 101 feet. Oh, wrong. Miles. So that means it's 101 miles to the horizon. All right, guys. Do your quizzes, and that's it. Hope this helps. So I can get back and stop this. I don't know.